Welcome back. So again, we're jumping to a new topic in this note. So we're moving from composite functions into inverse functions. So inverse relations, what we're talking about is inverses happen when you can reverse the x and the y's. So what I mean by that is if you take this first table, the inverse would be flipping all the x and y values. Okay? The inverse to this, again, flipping all the x and y values. So that's the basis of inverses. All you're doing is flipping x and y's. Well, you can actually take that same concept and the same thing works in equations. So I want you to think, in an equation, you can flip x and y, just like we were doing in those data tables. You can flip x and y. And now the inverse equation that we're looking for is when you resolve it for y. So what that means, to resolve for y, I'm going to have to subtract the 1 over and divide everything by 2. And that is how you get your inverse equation. So let's take a look at another example. Again, flip my x and y. And now I'm going to resolve this whole thing for y. So I'm going to subtract the 7. And now how do I undo a square? Well, I need to square root. Now remember, when you square root in an equation, you always end up with a plus or minus. So you absolutely can't forget that plus or minus for this equation. It is necessary when you're solving this. All right, and for this one, again, switching x and y. Well, how do you undo a square root? Well, you square both sides. That gets rid of the square root. And now you subtract 4. And you have y back by itself. So this idea of inverses is actually not too horribly difficult, okay? You just have to know to switch x and y and then do whatever it takes to get y back by itself again. And once you do that, you're done and you have your inverse equation. All right, so this one ended up being pretty quick again. So make sure you have all this written down and then make sure you ask if you have any questions on it, please.